Terms, path functions, state functions. System, specified object which is under study. Surroundings, other than system. Boundary, which separates system and surroundings. Open system, both heat and matter exchange with surroundings. Closed system, only heat exchange with surroundings, not matter. Isolated system, neither heat nor matter exchange with surroundings. If a system at temperature T, volume V, it is made into two. Volume becomes half. What about temperature? Volume is an extensive property. Temperature is an intensive property. Extensive property, the property which depends upon total matter. Intensive property does not depend upon total matter. Path function. Heat and work are path functions which depends upon direction. For a system, internal energy U, heat given to the system plus Q. From the system, heat comes out minus Q. Work done on the system plus W done by the system minus W. du is equal to dq plus dw. First law of thermodynamics. Path function. Heat. Flow of heat is directly proportional to difference in temperature. Q directly proportional to delta T. Q is equal to C delta T, where C is equal to heat capacity or molar heat capacity. Q is equal to Ms delta T. S is equal to specific heat capacity M, molar mass. Specific heat capacity. The quantity of heat is required to raise 1 degree Celsius through 1 gram of substance. Heat capacity. The quantity of heat is required to raise 1 degree Celsius through 1 mole of substance. Heat capacity at constant volume. Here Q is equal to Cv delta T is equal to delta U is equal to change in internal energy. Heat capacity at constant pressure Cp. Q is equal to Cp delta T is equal to delta H is equal to change in enthalpy. Delta H is equal to delta U plus P delta V. By substituting the values, Cp minus Cv is equal to R. Work. Work done in isothermal process. Isothermal, constant temperature, delta T is equal to 0. Delta T is directly proportional to delta U. Delta U is equal to 0. Work done in isothermal reversible to and fro process. W is equal to minus 2.303 nRT log V2 by V1. Work done in isothermal irreversible process, only 2. In vacuum or due to free expansion, P external is equal to 0, so work done is equal to 0. If constant pressure has been given, work done is equal to minus P external into V2 minus V1. Work done in adiabatic process. Adiabatic process, constant heat, delta Q is equal to 0. W is equal to NCV into T2 minus T1 is equal to N R upon gamma minus 1 T2 minus T1 is equal to N 1 by gamma minus 1 into P2 minus P1 V1. Reversible and irreversible depends upon T2. T2 is equal to T1 into V1 by V2 whole power gamma minus 1, where gamma is equal to the ratio of Cp upon Cv for monoatomic 5 by 3, diatomic 7 by 5, triatomic 4 by 3 for nonlinear. Delta U, change in internal energy. Delta H, change in enthalpy. Delta S, change in entropy. Delta G, change in Gibbs free energy. State function. Delta U, change in internal energy, calculated by bomb calorimeter. Delta U is equal to minus H into m theta by small m, where m is equal to molecular weight, small m weight in grams, theta rising temperature, H specific heat of calorimeter. H is equal to m2 into T2 minus T1 by T3 minus T1 minus m1. m1 at low temperature, m2 at high temperature, m3 at mixed temperature. Delta H, change in enthalpy. Delta H is equal to delta E plus delta N RT. Hint, delta N, heat of formation, heat liberated or absorbed when 1 mole of substance formed from its elements. Example, C plus O2 gives CO2, but not CO plus half O2 gives CO2. Here CO is a compound, not an element. If heat of formation of reactants and products has been given in a problem, then delta H is equal to sum of enthalpies of products minus sum of enthalpies of reactants. Delta H, change in enthalpy, heat of combustion, heat liberated when 1 mole of substance completely oxidized by burning. It is always exothermic. C plus O2 gives us to CO2, but not C plus half O to CO. Here CO, carbon oxidation number is plus 2. If it is completely oxidized, it should attain plus 4 oxidation number. So C plus O2 gives us to CO2 is a example for combustion. If heat of combustion or decomposition of reactants and products has been given in a problem, formula delta H is equal to sum of enthalpies of reactants minus sum of enthalpies of products. Heat of neutralization, heat liberated when 1 equivalent of acid reacts with 1 equivalent of base. It is always exothermic. It is calculated by formation of 1 water molecule. H plus OH minus gives H2O. Delta H is equal to minus 13.7 kilocalories per mole or minus 57.3 kilojoules per mole. If heat of ionization of weak acid or base is given, then heat of neutralization is equal to minus 57.3 kilojoules per mole plus heat of ionization energy. Enthalpy of sublimation, enthalpy fusion plus enthalpy vaporization, enthalpy of solution, enthalpy hydration plus enthalpy lattice energy, enthalpy of hydration of anhydrous compound, enthalpy of anhydrous salt minus hydrated salt, enthalpy of resonance, Enthalpy of experimental minus enthalpy of theoretical. Delta S, change in entropy, measurement of randomness or disorderness. Characteristics. For isolated system, delta S total is equal to sum of system plus surrounding. For adiabatic process, all are equal to 0. For a reversible system, delta S system is equal to minus delta S surrounding. For irreversible system, delta S system plus delta S surrounding greater than 0. Delta S, change in entropy. For an ideal gas, delta S is equal to NCV ln T2 by T1 plus NR ln V2 by V1. Or delta S is equal to NCP ln T2 by T1 plus NR ln P1 by P2. For a phase transition, solid gives liquid. Delta S is equal to entropy liquid minus entropy solid. Delta H for fusion by temperature is equal to 6 kilojoules per mole by 273 for water molecule. Liquid to gas, delta S is equal to entropy of gas minus entropy of liquid. Delta H, vaporization by temperature, is equal to 40.6 kilojoules per mole upon 373 for water. For an equation, Pa plus Qb gives Mc plus Nd. Change in entropy at standard conditions. Entropy of products minus entropy of reactants. Gibbs free energy. Excess of energy utilized for useful work. Decrease in Gibbs free energy is equal to work done by the cell. Delta G naught is equal to NF E naught cell is equal to minus P delta V. Delta G is equal to delta H minus T delta S.